What's up guys, welcome back to the channel. In this video tutorial we are going to solve another question regarding the binary trees, which is basically the vertical order traversal. So let's start this video. Before starting this video, I request you to watch all the videos in a series. In this Shivaya's tree series, I am making all the important concepts regarding the trees from basic to advanced, and all those questions which are might asked in the interviews. And make sure you are watching all my previous videos, and also you have bookmarked the my Shivaya's tree series. So let's get started. So here, if you carefully see, what the question is, vertical order traversal. So what is a vertical order traversal? Let's first understand. So let me first draw a binary tree. So here I am drawing a binary tree. This is my binary tree. So I having a 2 here. Let's take the right children of 1 as a 3. Clear? Now, so after that, let's take the left children of a 3 as a 4. And let's take the right children of a 3 as a 5. Clear? And let us take a left children of a 2 as a 6 only. So let us suppose we have taken this binary tree. So what about the vertical order traversal is? In the previous video we have discussed about the level order traversal. In that one we go through the levels. We go through this particular level, we go through this particular level, and then this particular level. And from left to right we take all the nodes, like this one, then this one, then this one. We have made a video on that particular topic. You can check out these videos in the link in the description. So in this video we are going to discuss the topic that is a vertical order traversal. So let me explain what a vertical order traversal is. So let us see. So basically the vertical order traversal is what? If we create a vertical axis, so let us take this is a one vertical axis. Let me create a line here. This is a one vertical axis. Okay. Vertical axis means from up to down. Let us take this another vertical axis. Clear? I am taking a vertical axis only. I am basically drawing the vertical axis on this binary tree. So let us take this another vertical axis. Now let us take this another vertical axis. I am just creating a dashed line which is representing the vertical axis, y axis obviously. So this is another vertical axis. Let's say, let's take this vertical axis also. Okay, so this is another vertical axis of this binary tree, and let us take this vertical axis. Okay, so this is another vertical axis. So if I talk about the vertical order traversal of a tree, so let me explain what it is. Let me erase this particular line. Yes, if I talk about the vertical order traversal of this tree, so if I divide this tree into a different vertical axis, different y axis, let us assume this axis is a, because it is a root node na, so let us assume this axis is a 0, vertical axis 0. In the right side, when we move to the right side, we will increment the vertical axis. So obviously it will be a 1 and it will be a 2. Similarly, whenever we move to the left side of the current vertical axis, it will be decremented by 1. So obviously here will be a 0 minus 1, that is a minus 1, and here will be a minus 1 minus 1, that is a minus 2. So these are the different vertical axes of this binary tree. So what is the vertical order traversal? Let us understand. So vertical order traversal means nothing but first of all we need to print this node, this 6 in the traversal. Then we need to go to this, first we have gone to this particular vertical axis, and how many number of nodes are there in this vertical axis? Only a single node, that is 6. Then we go to this vertical axis because all the nodes in the previous vertical axis has been traversed. So in this minus 1 vertical axis we only having this single node, that is 2. So what we will do is we will simply take this 2 in our traversal. Then we go to this vertical axis, and as you can see in this particular vertical axis we are having a two nodes. One is this particular one, we will take it in a traversal. Another one is this particular 4, so we will take it into the traversal. Okay, and in this vertical axis all the nodes are completed. So let's move to this vertical axis. So in this particular vertical axis we are having a node 3 only. So let us take the 3 into the traversal. So I am taking this 3 into traversal, and then we go to this vertical axis 2. As you can see, there is only one node, that is a 5. So I will simply take a 5 in the traversal. So let us write into the traversal. This is a 5 here. So this will be the vertical order traversal of this binary tree. So if I talk about what is the vertical order traversal of the binary tree, nothing but it is simply a means, you can say that you can simply say that in the different vertical axis, all the nodes from up to down, when we take, it will be the vertical order traversal. We will start from the leftmost vertical axis like this y minus 2, and we will go from up to down and see what are the different nodes are present. So we will simply add it to the traversal. So first we take to 6, then we go to 2, then 1 and 4, because in this particular vertical axis we are having a 1 and 4. So all the nodes we have to take. One more important thing is, let us suppose our 2 having a right children as a 9. So where this 9 will be present? This 9 will be present at this particular vertical axis. Okay, so this 9 will be present at this particular vertical axis. This is very important. Similarly, if I take the right children of this 6, like let's say 7, it will be present in the vertical axis -1. So you need to understand some of these points. So we need to take care of the vertical axis, and just we need to take every vertical axis. All the nodes from top to bottom present in that particular vertical axis will be the answer. So let us see what will be the approach for calculating the vertical axis in order to solve this question. So let us start doing this question. So guys, let us see how we will be solving this question. So first of all, we have taken as a this binary tree. As you can see, I have taken the different vertical axis. So the vertical axis starting from the root node will be 0, and all the nodes like this pattern. If you can carefully see, in my previous session I have explained how will we take the various vertical axis. So here I have taken 0, here I have taken 1, here 2, and here -1, and here -2. As we move to the left part, the vertical axis is decreased by 1, and as we move to the right part, the vertical axis will be increased by 1. So what we will do is, so we will simply do a pre-order traversal. Okay, so we will be simply doing a pre-order traversal, and here we have taken a map. Clear? Here we have taken a map. This map will store what are the different nodes present at any vertical axis. So for example, if I go to this vertical axis 0, so it will be storing the node present 1 at this particular vertical axis. Okay, so then again if it comes to this axis, it will be storing 5 at this particular axis. I hope you understand. So means we have taken a map in order to store what are the different nodes present at the vertical axis. So it will be representing at that particular vertical axis what are the nodes will be present. So the type of this map will be a integer comma vector. So I am taking a vector here in this portion to store the different nodes present at any particular vertical axis. So how we will do, let us see. So first of all, I will create a function known as a vertical order traversal. When I call that function, I will start from this particular node. Clear? What I will do, I will simply create a key of this particular vertical axis. Initially I will call this function for a 0, the vertical axis as a 0. So what I will do, I will simply create a key in my map for a 0 and add a node 1 to that. It means that at vertical axis 0, a node 1 is present. Okay, then I will do a left recursion call. When I go to the left, this is very important. When I go to the left part, when I go to this left part, as you can see, the vertical axis is decreased by 1. So what I will do, whatever the value of the vertical axis in this particular stack frame, that will be decremented by 1 when I am calling a left recursion call. So I will go to the left recursion call. Here the value of the vertical axis is a -1. So what I will do, I will create a key for a -1, and what is the node at that particular axis? As you can see, it is a 2. So I will simply add a 2 here. Then what I will do, again I will do a left recursion call. If you can see, whenever I am doing a left recursion call, I am decrementing the current value of the axis, because as we know that as we are moving to the left axis, basically the horizontal distance is decremented, and as we move to the right axis, the horizontal index will be distance will be incremented by 1. Clear? So I hope you understand. So when we go to from this 2 to 4, the vertical axis is -1 and here it will become -2. So we will create a key -2 showing that at that particular vertical axis 4 is one of the node present at that particular vertical axis. Now we will go to its left part. As you can see, nothing is present, so it is a base condition. We will simply return back to here. Again we will go to its right part, because it often happens in the pre-order traversal. First of all we access the root, then we go to its left part, then we move to its right part. So here is nothing present, and we come back, and when we move to this particular one, as you can see, now I am moving to its right part, and when I am moving to its right part, as you can see, there is nothing present. So can I say there is nothing present? Of course there is nothing present, so I will simply return. Now you may say that it is a 5, so it is not a children of a 2, so here is a null. I will simply return back to here, and then I come back to this one. Now from 1 I will go to its right part, and whenever I am going from to its right part, whatever the current value of my axis, it will be incremented by 1. So from 0 it will come 1. So now I am at the axis 1, and what is the node is? It is a 3. So what I will do, if there is a previous key present in this, no, there is no previous key, as a 1 is present in this, so I will create a simply new key and simply add a element 3 in this, representing that at the axis 1 3 is present. Now I will move to its left part, and whenever I am moving to its left part, what I said is I will decrement the value of the current vertical axis, because whenever we move to the left part, the value is continuously decrementing by 1. So when we move to its left recursive call, it will become 0. So I will do is what? Simply, already I having a key for 0. So what I will do is I will simply add element that is a 5 to this, it representing that a 5 is the element which is present in the vertical axis 0. Now I will move to the left part. Of course there is nothing present, so I will simply return. I go to the right part. Of course there is nothing present, so I will simply return back to here. And now I go to back to 3, and from this 3, when we go to the right recursive call for 6, I again repeat that whenever we are doing the right recursive call, we will increment the current vertical axis by 1. So now it will become 2. So what we will do, we will create a new key for the 2 and add the 6 element to that particular node field. So it will be a 6. So here will be a comma, it is not a 50, it is a 1 and 5. So here will be a 6. Now I will move to its left part, there is nothing, and I will move to its right part, there is nothing, and then my traversal has been completed. So I come back. As you can see, carefully see, in this vector I have calculated all the nodes present at all the vertical axes. Clear? So at the 0 vertical axis I am having a 1 and 5, at the -1 vertical axis I am having a 2, at the -2 vertical axis I am having a 4. So what I need to do now is I need to simply sort this. I need to simply sort this according to ascending order. So when I sort this according to ascending order, all the corresponding second node values to this will be my answer. So one more important thing is that we are using a inbuilt STL map. So automatically inbuilt STL map will sort it. So the map will store it like -2 will come first, -1 will come then second, then our 0 will comes, then our 1 will come, and then 2 will come. So automatically it is a functionality of a map. It will store the values in the ascending order of the keys. So it will be storing information like this way. So -2 will be having a node 4, -1 will be having a node 2, and 0 having a node 1 and 5, 0 axis. Automatically this is a property of a map that it will store the values according to the ascending order of the keys, and 1 having a 3 and 2 having a 6. So what we need to do now is we need to simply print these values, and we will get our vertical order traversal, which is nothing but a 4, 2, 1, 5, 3 and 6. So I hope you understand how it actually works. So basically we are doing nothing, we are simply doing a pre-order traversal, and when we are doing a pre-order traversal, whenever we are going to a left recursion call, we are decrementing the vertical axis by 1, and whenever we are going to right recursive call, right subtree, we are incrementing the current vertical axis by 1. Clear? The concept is very simple, because whenever we are moving to the left part, the vertical axis is decremented by 1, and when we go to the right part, the horizontal distance is incremented, and whenever we are reaching at any node, what we are doing is we will simply taking a track that in which axis it is lying, and simply we will add that node to that particular axis. Clear? We are taking account that at that particular axis these nodes are present. So I hope you understand how this whole thing works. So let me explain the code. Here first of all we have defined the node structure as we have usually taken in all the videos. Here we have simply taken a create function to create a basically binary tree. After that, here is the vertical order traversal function. First of all, I have created a tree, and then I have taken a map. The type of a map is an integer comma vector, because as you can see, for any vertical axis there may be multiple nodes can be present at any vertical axis. For storing a multiple nodes, I have taken simply a vector here. So I hope you understand. And then initially I have taken the axis as a 0 because I will always start from the root node. Then there is the vertical order traversal function which is receiving a root pointer, current axis and the map. So I am passing this map by reference. So any type of change will be reflected in this map for every stack frame. So what is the base condition? When the root is null, we need to simply return. As we have seen, when there is a root is a null, we need to return, nothing to do. And what we have done is we have simply m.axis means we have created a key. If it is already present, then it will push back to corresponding vector corresponding to that key. We will simply push back the data, and if it is not present, key is not present, it will automatically create a key, and corresponding to that key it will simply push back the node in that particular vector. And then we are recursively calling this function to the root to left, and when we are calling this function for root to left, we are decrementing the axis value by 1, and when we are calling this function for root to right, we are incrementing the value by 1, and finally we are printed here. So here we need to do one more thing. So for int I is equals to, let me explain what I am doing. We need to print the values of a vector. For int I is equals to 0, I is less than m to second I plus plus. So I will simply see out m to second of I. Clear? So what I have done is I will simply iterating over the vector. Here I have created an iterator, and the second value means the vector, and what we will do is whatever the second value which is a vector size, I will iterate over that vector, and simply we will printing that stuff. So let us try to solve let us try for this particular binary tree in which I having a 1 as a root node. Let's take input 1 as a root node. Left children of a 1 is a 2, and the left children of a 2 is a 4. Left children of 4 is nothing, right children of 4 is also nothing. So what will be the right children of 2? Right children of 4 is nothing, so let me take it as a -1. And then right children of 1 is 3, and the left children of 3 is a 5. Left children of 5 is nothing, right children is also nothing. Right children of 3 is a 6, and right children of 6 is nothing, and left and right children of 6 is nothing. So let me save it and try to run it. So it's showing me an error. What is the error? Let us see and try to solve it. So let me explain. Okay, so we need to write here itr not m. So we need to write here itr instead of m. Now I think it's fine. Save it and run it. As you can see, this is the vertical order traversal of our binary tree 4 to 1, 5, 3 and 6. As you can see, this is 4 to 1, 5, 3 and 6. I hope you like this video. If you really interested in all these videos I am making, so make sure you please subscribe my channel. I will be making a great content if you support me, and I consume my lot of time in making the videos for you, because I am also a student. So make sure you subscribe my channel and also press the bell icon and share these videos with your programming groups. So meet you next video. Until then, bye bye.